Hello all, today we'll be studying about number system. Before we get into the topic, you should be aware of why we have to study this number system. Say for example, in case if you want to measure the height of a tree, or if you want to calculate the weight of a particular object, or if you want to calculate the distance covered, then in that case, you need some numbers for measuring it, right? And how are we going to study about these numbers? And that is why the number system comes into picture. I hope now you might have understood why we are going to study this number system. Okay. Number systems are broadly classified into two types, that is positional number system and non-positional number system. Positional number system, as the name implies, it means we are going to assign some positional weight to each particular digit in a number. Say for example, positional number system, usually it varies from 0, 1, 2, 3 and then it goes on up till n. When you are assigning positional weight to each particular digit in a number, meaning, let me take the number 346. What does it mean? The positional weight that is assigned to the particular number 6, it is in unit position. The positional weight assigned to the number 4, it is in tens position, and the positional weight assigned to the number 3, it is in hundreds position. These are the positional weights attached to that particular digit in this particular number. Clear? What is positional number system? Fine. This is not the case with the non-positional number system. In non-positional number system, there is no concept of assigning weights to any particular position in that particular number. Example for this is Roman numbers. You all very well know how to write a Roman number. It starts from 1, 2, 3, 4 and then it goes on. Right? We are following positional number system in our day-to-day life and we are not following non-positional number system. Can anyone tell me the reason for it? This is because of the number 0. Have you ever wondered of representing number 0 in Roman numbers? Have you ever thought about why we are always starting with the number 1, 2 and then it goes on in a Roman number, and why we are not starting with the number 0? That is because we cannot represent 0 in Roman number. But 0 is very important in our day-to-day life. For example, in all the digital electronic devices that we have in our current scenario, say for example, if you take a mobile phone or if you take a laptop or any electronic devices, digital electronic device for that matter, every device, every digital device follow binary number system. And you all know binary number system, it depends only on two numbers, that is 0 and 1. If we are not able to represent the number 0 in non-positional number system, then we won't be able to use this non-positional number system in any of the digital electronic devices. That is the reason we are not following non-positional numbers. Understood why we are following only positional number system and why we are not following non-positional number system? Okay. There are 4 different types of positional number system. That is binary, decimal, octal and hexadecimal. Binary number system, decimal number system, octal number system and hexadecimal number system. We'll be studying about each and every number system in detail. Let's start with binary number system. As the name indicates, bi, meaning 2. The base for this number system is 2. That is, it can hold only 2 values. What are the values? It can hold either 1 or 0. Clear? The binary number system is always represented as a sequence of bits. What does it mean? Every single digit in binary number system is called a bit. And a sequence of bits meaning any combination of bits. Any combination of 4 bit is called a nibble. And a combination of 8 bits is called a byte. Clear? 4 bits combination is called a nibble, and 8 bits combination is called a byte, where bit, the meaning of bit is every single digit. Every single digit is called a bit. Clear? Combination of 16 bits is called a word, and a combination of 32 bits is called a double word. Clear? This binary system is mainly used in almost all the digital electronic devices that we have in our day-to-day life. Understood where we will be applying this binary number system? I hope you are clear with the binary number system. Now let's move on with the decimal number system. The base for decimal number system, it is number 10. When I mention base, it means this particular number system can hold only 10 digits. Clear? Say for example, the base for binary number system, it is 2, meaning this number system can hold only 2 values, that is 0 and 1. In a similar way, when I mention the base for decimal number system as 10, it means this number system can hold only the numbers from 0 to 9. Is that clear? Fine. This number system, it is mainly used in almost all the real-time applications in our day-to-day life. Coming to octal number system, the base for octal number system, it is 8. That is, this octal number system can hold the values only from 0 to 7. It cannot hold any value that is greater than 7. Understood? The application for octal number system, it is aviation industry. The main application is aviation industry. Say for example, if an aircraft wants to communicate with the air traffic controller, like in case if the aircraft want to take off, or in case if it want to land, or if any communication the aircraft wants to communicate with the air traffic controller, the transponders in the aircraft send a unique octal code to the air traffic controller. Based on this unique code, the ATC will easily identify from which particular aircraft the signal has been received. And that unique code is actually based on octal number system. Clear? Coming to a hexadecimal number system, the base for hexadecimal number system, it is 16. All these number systems, that is the binary number system, decimal number system and octal number system, are all numeric number systems, whereas hexadecimal number system is alphanumeric. That is, it can hold both the alphabets as well as the numbers. The numbers, since the base of it is 16, it means it can hold only 16 digits, right? Of the 16 digits, 0 to 9 it can hold, and the remaining numbers, that is 10, 11, 12, 13, 14, 15, these are represented with alphabets. Like 10 is represented with A, 11 is represented with B, 12 is represented with C, 13 is represented with D, 14 is represented with E, and 15 is represented with F. Altogether, it can hold the numbers 0 to 9 and the alphabets from A to F, where A corresponds to the value 10, B corresponds to the value 11, and then C corresponds to 12, D corresponds to 13, E corresponds to 14, and F corresponds to 15. When you look into the applications of where we will be using this hexadecimal number system, it is mainly used to specify the memory locations, the address of any particular memory in your computer system. Say for example, if you want to store any data in the memory of a system, there will be a unique memory location where this particular data has been stored. That particular memory locations are usually represented in hexadecimal format. Understood? We'll be studying about this in detail when we are discussing about hexadecimal number system in the subsequent lectures. For now, I hope you are clear with what a number system is, why we are studying this number system, what are the two broad categories of number system, that is positional number system and non-positional number system, and why are we following only positional number system, and what are the four main categories of positional number system, that is binary number system, decimal number system, octal number system, and hexadecimal number system. What is the base for each system and where we are applying these systems and what numbers can it hold. I hope you are clear with this lecture. In the next lecture, we'll be studying about the number conversions. like how you will be converting the binary number to a decimal number, and how we'll be converting a binary to an octal number and a binary to a hexadecimal number. In a similar way, we'll be studying about how we are going to convert a decimal number to a binary, decimal to an octal, and decimal to hexadecimal. In a similar way, how we'll be converting octal to the other three numbers and hexadecimal to the other three numbers. Apart from this conversion, we will also be studying about where we will be using this conversion and why we have to use this conversion in the next video. I hope you're clear with this lecture. If you find my lectures informative and useful, please do like, share and subscribe to my channel. Thank you.